Okay, this question is from the sample paper 2014 called Podrick's Pension. The first part of the question were to work out the present value of a future payment of 20,000 euros in 1 year's time, if it's 3%. Well, if we look up the tables, we see formulas for future value and present value. In this question, the future value is 20,000 euros, the time is 1, and the rate is 3% or 0.03. So subbing these numbers into the formula for present value, it gives us 19,417.48. Now in the second question, in terms of t, if it wasn't 1 year but was t years, and all other things remain unchanged, so we're replacing the 1 with t this time, then the present value would be, using the same formula, 20,000 divided by 1.03 to the power of t. Now this is useful in the next part of the question. This time we're to show, using a sum of geometric series, calculate the value of the pension on retirement that will give them 20,000 to start of each month. So this question, what we're looking at is a total of a series of present values. The first of these is 20,000 is paid in at the start of the first year. It would not be earning interest because it's the start of the year. The second one would be earning interest for 1 year. And this goes right down over 25 years. The last one is earning interest for 24 years. So we set up this set of present values. Now we wish to sum these. Again, if we look up the tables, we see that the formula for the sum of a geometric series, Sn, is given to a times bracket 1 minus r to the power of n all over 1 minus r, where a is the first term, r is the common ratio, and n is the number of terms. Well, I'm going to call the first term 20,000. Our ratio then going from one term to the next would be 1 over 1.03, and we see that there's 25 terms. Subbing these values into the formula, the total of these present values, which is our pension, sub it all in carefully, and then just take out your calculator, and using the fraction button on the calculator, we see this gives us a value of 358,710.84. Okay, the next part, we're to work out a monthly equivalent rate of interest. I'm going to call it R. This is something should be learned off. Expect this question. So we're changing 3% to a monthly equivalent rate, or that's the annual equivalent rate. So the 3% applied once is the same as the monthly equivalent applied 12 times. This gives us that the monthly equivalent rate is the 12th root of 1.03 minus 1. Using the calculator, this gives us 0.002466 to 4 significant figures. And if we write this as a percentage, again holding on to the 4 figures, it's 0.2466%. Okay, the next part we're to write down in terms of N and P the value on the retirement date of a payment P. This is the future value, so we write down the future value formula. In this question, the only information we have is that the monthly equivalent rate is going to be 0.002466. So just subbing in this value into the formula, the future value is P times 1.002466 all to the power of n. And that's all that question's asking. But this again is useful in the next part of the question. If there's 480 equal payments, what value of P would give us the required pension fund? So let's remember from the first part what the pension fund was. So the pension fund that we worked out in the earlier part of the question was 358,710.84. And what we're looking for is the sum of future values that would amount to this amount. Now we see each of the future values is given by the formula P 1.002466 to the power of n. The first one of these in this series is something that was earning interest for 480 months. And this goes right down to the last one. The last payment will only have been earning interest for 1 month. So using this, we want to sum this geometric series. Again, write down the geometric series formula. And we're going to decide to call the first term any term we want, but it's easier if we call this first term kind of the last in this sequence. So I'm going to call A P by 1.002466. The common ratio getting from one term to the next then will be 1.002466, and there are 480 terms. So we sub each of these numbers carefully into the geometric series formula. And we know that the value of this is our pension fund. That's what this amounts to. So manipulating this formula, this gives us that P has this value here. And carefully put this into the calculator, and we get the answer 390.17 cents. Okay, the last part of the question, we're changing the number of years. What if we take 10 years off? Well, 10 years is 120 months. So instead of 480 months, we're going to be paying into the pension for 360 months. Now, nothing else in the formula changes. So if you look at the answer above, the only thing we're changing is we're exchanging 480 for 360. So each payment will be given by this amount here. So it's exactly the same as the last part of the last question, but this time we're just putting it to the power of 360 instead of 480. Again, carefully sub this into the calculator, and we see that it's increased by quite an amount. The total this time is 618.35.